screen?
Yes, we do.
Excellent. So my name is Andreás Csepinszky. I am based in Hungary. I'm representing MST, the Hungarian National Standardization Organization. I am also a delegate, more observing delegate to ISO TC 211, but my activity goes more on ISO TC 204, intelligent transport systems. And no, I'm talking to you because of a proposal which comes from TC 204, but which is concerning TC 211. And let's give you first a little bit of the background. So what you see here is the standards ecosystem of mobility from the perspective of maps, and the maps and all map related standardized functions and different other services are extremely complex. What I would like to highlight here is that we have a very fragmented and very complex situation that we need to serve with data for very specific purposes. And I would like just to give you a very quick highlights and how it looks like in the real world. And this is not theoretical; it is something that happens in the automotive and the ITS industry. So we are starting from map infrastructure. Map is being provided to a number of services used in vehicle. The standards that are actually being used are a number. So the green boxes are industry standardization bodies. The blue boxes are European or international standardization bodies. If you have some green boxes in blue boxes, that means that they have liaisons and working together. So we have a situation where different map data, dynamic and static map data, are being served into the vehicles. The vehicles are consuming it, and we are talking about navigation services, GPS you call them, or we are talking about automated driving services. And these functions are consuming the data that are provided. Also, we receive sensor information coming from the onboard sensors of the vehicles. Also, we are talking about eGNSS or GNSS data coming in, helping the localization positioning of the vehicles. In return, the vehicle is sometimes logically extended. We call them extended vehicles. This is ISO TC 22 subcommittee 31, which is defined this extension of the physical vehicle into the logical domain. And this is important because of many considerations, among others, cybersecurity. Vehicles are providing probe vehicle data from the perspective of their perception services, from their positioning services. These information are harvested from the vehicles and being used in a number of services. Digital infrastructure is using it, considering many different aspects. These digital infrastructure may consist of services from traffic management centers, public safety answering points, road operators, power grid operators, public authorities, public transport operators, national access points, etc. So you have a high number of different organizations harvesting and needing this kind of information. Also, we will need to talk about what we call cooperative ITS. It's an ecosystem in itself. You may know under the name of V2X. This is a very much dynamic information exchange between vehicles and vehicle and infrastructure. And this is also serves as probe vehicle data for certain services in the digital infrastructure. The loop between the vehicle and the map infrastructure is closed by services between digital infrastructure and the map infrastructure. We have services that provides information about changes, about different changes made by the authorities or made by accidentally by nature. So these changes goes into the map infrastructure. And then also we are considering the proprietary mapping services done by map providers, map industry like TomTom here, etc. Also, it is very important to consider that there are artificial intelligence and big data standards that are highly relevant in all of the segments, all actors that you see here. Map infrastructure, map makers are using AI and big data. OEMs are using artificial intelligence and big data. Vehicles are using, digital infrastructures are using. Different other services like safety relevance services, like type approval services are highly demanded as well. Ethical considerations, payment, digital twin and data spaces are also very much in the loop of the attention of this ecosystem here. In addition to that, cybersecurity is #1 consideration in the mobility because of the high sensible and highly vulnerable nature of transportation. Physical infrastructure is highly important because of simulation and testing. In the domain of automated driving testing, vehicle in the loop testing is highly important, and it is impossible to do without the digital map that we know under the name of OpenDrive in the simulations. So this is the complexity what we have in the transport or ITS domain with regards of maps or map data ecosystem. Now, the problem statement that I would like to underline here is that we have a mission to provide interoperable maps in the ITS domain. Therefore, we have to have agreement, and we are missing this agreement so far, except in some industry specifications like NDS, and you see NDS there, and I will just give you some hint after that. You can see here the ecosystem of the Open Auto Drive Forum. Open Auto Drive Forum is a platform that was created by the Navigation Data Standard Association, ADASIS, the ADAS Interface Specification Standard Organization. Sensor is the Sensor Interface Specification Association, the Traveler Information Services Association, and TNITS, which is also an industry organization having its specification developed under CEN TC 278 working group 7. And now it is merged with DATEX2, becoming the part 14. The importance of this ecosystem is that we wanted to create an infinite data loop that is using data for the purpose of automated driving and harvesting data from vehicles in order to keep the map as up-to-date and as trustworthy as possible. To imagine this data loop, it is very important to understand that all the maps that we need for automated driving has to be as up-to-date, as accurate as possible. And as of today, all mapping services of map makers are unable to fulfill the requirements to have everything updated on real time. So therefore, the requirement to get harvesting probe vehicle data as much as possible. This purpose was piloted and proven as feasible by the project which is called Data for Road Safety. This project now involves tens of millions of vehicles in Europe all around, which are harvesting data from the vehicle fleets, aggregating by an entity in Luxembourg, and providing the aggregated data to map makers like TomTom and HERE, who provides in return to the vehicle fleets as updated traffic and map information. So it is proven that this data loop is feasible, it is working, and it is working on the industry scale. The specificity of this is that we don't have an ISO standard that is implemented in the vehicles. We have industry standards such as NDS Classic, which has a different approach to provide digital maps for vehicles. And we have NDS Live, which is much more for the purpose of providing map as a service kind of service today, because NDS Live is targeting HD maps or HAD maps, highly automated driving maps for this specific case. So after due consideration, in ISO TC 204, Working Group 3, together with ISO TC 211, Joint Working Group 11, we had an initiative called Map Update Task Force, Joint Task Force. And actually, we've been running that exercise quite a long time because the ITS community needs an update method of maps. And so far, we identified two potential consumers, generic ITS services, which we call generally, or in the most of the times, location-based services, LBS, and automated driving functions, which are referencing map data as a priori sensor data. So, and these services are dependent on geospatial data that must be up-to-date, traceable, and distributable across many different clients. The gap that we identified is that it's not enough to access map data, but we have to fulfill requirements of map updates, how to update different maps using different strategies according to the context, according to the physical and contextual specificities of map updates. Therefore, we have to fulfill the following requirements. The operational needs are high-frequency updates that are needed for automated driving, for instance, and strong traceability, because we will need to be sure where from the data is coming. The actual reality is that the update methods are absolutely fragmented. There is no common understanding on that, and we have proprietary implementations. Proprietary meaning NDS is doing that today. The goal to do this exercise for this in the context of this technical report is that we would like to have a common reference approach and interoperable pathway that is fulfilling requirements on incremental change, on versioning, provenance, integrity checking, and controlled distribution. This TR would serve as a bridge between the requirements of ITS and industry practice, and also between the already existing APIs that is provided by ISO TC211. We also very much keen on how this reference approach is defined, considering resource models, behavioral rules, and interface patterns. Update mechanisms are very specific in these, and the goal is to shape the form of a future possible standard where we have testable behaviors and conformance options. Why? Because in the automotive industry and in the ITS industry, we have to fulfill very, very serious quality requirements. We've been discussing the title of the proposal, so it's an extension of map access APIs for map and other spatial data update purposes, and that would be a proposal. Okay, this is how it looks like. How the governance. We've been discussing in ISO TC204 Working Group 3, also in Joint Working Group 11, how to do it in a way that we won't lose the focus on what we have already in ISO TC211, but also to keep in mind the requirements of ITS. So ISO TC204 Working Group 3 keeps the ITS use case requirements and validation as an input for the exercise. Also because of the very strong relationship between Working Group 3 of ISO TC204 and CEN TC27 Working Group 7, we have a working liaison. Even we are working together under the Vienna Agreement. We think that this also relevant for regional ITS alignment. And as you may know, in Europe, the ITS directive with its delegated regulations have an important role in the deployment of ITS services. So we have some very important elements on safety-related traffic information, in real-time traffic information, and so on. So we have a number of requirements in this. Also, we would like to avoid any duplication and parallel ITS geospatial approaches. We would like to align with API architectures that ISO TC211 started to develop, and ISO 19177 is fresh. The part 1 was published 2026, and we are very much aware that OGC API series is available. Therefore, we would like to also consider that ISO TC211 has a strong link with OGC. Also, we would like to consider the industry map standards, because in the real life, in the industry today, these are the ones which are being used in mass production in the automotive industry. Now, the task that we have. So first of all, the most important, we would like to understand how ISO 19177 is working, how it is specified, and what it is capable of. So the architecture and the tiles related capabilities. We would like also to understand OGC API family of standards. We would like to know much about the future plans of ISO TC211 with regards of the OGC API specifications. Also, we would like to have a discussion with the industry specification, industry organization with regards of their specifications, while having experience of map providers using these industry specs for commercial services, OEMs requirements, automated driving system developers requirements, and also ITS service providers. So there is a market need that we would like to understand, and we would like to see what the actual API standard of ISO TC211 is capable to fulfill these requirements. We wouldn't like to have any proprietary endorsement, so we are looking for really international standardization and not proprietary one. So update semantics also, to understand for you what is the challenge for us. So we will need to go through the different aspects of the map and static and dynamic map update mechanism. We have to consider the different update models, replacement, full replacement. That means that we have to completely change the map database in the vehicle. Incremental updates, or the delta or patch mechanisms. Also, we would like to go and analyze state handling, the different snapshot, change set versions, validity times of the update mechanism. The geographic scope of update mechanisms, area of interest updated, or bounding boxes, or corridors. These are very, very important because we are dealing with vehicles where the coverage and bandwidth is limited. So sometimes we cannot simply update a full map, only part of the maps. Also, we would like to make analysis of how map update discovery and map update requests are handled, available updates, filters, and client requests. These are very specific in our industry. And also the reference model has to be defined at the end of the day, how to make use of resources, what are the behavior rules that we will need to use and implement, and what are the future possible conformance that we will need to rely on. So the expected outcome is an informative resource model and behavior rules that could be later become testable conformance class in a full international standard. So another aspect of this exercise is that a main requirement is the trustworthiness and integrity of the data that we will need in this kind of services. The provenance metadata, I have heard, and that was really a joy for my ears. The metadata standards are so much used in the in ISO TC211. In ISO TC204, we don't have. So now we are trying to adopt and learn from you in this regard. Also, checksums and signatures. We are talking about cybersecurity. This is something that integrity is a must, and that has to be complied. Idempotency and replay safety, as I mentioned, the map updates may be interrupted in any time because of loss of coverage, because of anything, to entering in a valley like in Switzerland, etc. So safe retry and validation is also a must. On the interface boundary, on the other side, we have the different delivery interactions. We have to deal with tile-based distributions, so how the cache behavior is dealt with in the client side. Tile update semantics is also important. Rendered maps where relevant update interpretation is has to be there, and feature-based delivery. So if we have an object that has to be updated, then we will need to be able to do that, and change representation. At the end of the day, we have to set up the boundaries. Out of scope, we are not doing anything. We don't want to define a normative API. We don't want to mandate internal map models or vendor-specific pipeline. We would like to have a requirement analysis. We would like to draw the standards landscape. We would like to create a reference approach and an example workflow, or more, maybe. And maybe we would like to see if there is a way for a normative follow-up. So the gap analysis may suggest conformance options, and candidates for testable behaviors can be also identified. So the decision logic at the end of the day is that if we have consensus and we see a maturity of the solution and testability is fine, then we can move into a normative ISO deliverable that is a matter of discussion yet. And the collaboration landscape is very clear. ISO TC 211 OGC on the GIS side, ISO TC 204 and CEN TC 278 on the ITS side, and we would like to have some interaction with industry specification communities as well. So by saying that, I give you the proposed scope, which was circulated by ISO TC 204 Working Group 3 until end of April. No comments was received and Working Group accepted. Now, the question is whether we can move forward and we can set up the collaboration and make this work item initiated by Joint Working Group 11 and start to work on it. So I would like to thank you for your attention. And if you have any questions, please don't hesitate.
Thank you very much, Andreas. That was great. What really struck me about your presentation is really what we've been talking about all day, which is that standards don't happen on themselves. You need a lot of collaboration. And certainly at TC 211, collaboration and harmonization are two real big buzzwords for us. So we're more than pleased to work with within the bounds of Joint Working Group 11 on this work. The other thing that struck me when we seen your first slide is how complex transport actually is. But I suppose that when you think about it quite rationally, if you're navigating a vehicle in a strange city, the vehicle's driving itself, there's a whole lot of data that has to flow around very, very quickly. So I'm not surprised that the standards environment within that is complex. Okay, so yeah, thanks very much for the outline of the presentation. Does anyone have any immediate questions? Trond already knows about this.
Yes, of course.
Thank you again for a very nice presentation. As I am the leader of Joint Working Group 11, so if you want to kind of raise your hands and participate in that environment, I'm here now. So it's just reach out to me. And thank you again, Andreas. It's a pleasure that you actually took time for this. I know it's very late in the evening in Europe now.
No, it's not so late. It's not so late. It's 9:30.
Okay, not that late. Thank you.
Any questions on that? Just my comment, great presentation. You've had a positive response online, so okay.